Hey friends, this is CSE1322, and this is going to be the last lecture I'm going to send you guys. This is the final exam review. So hopefully by the time that you guys are watching this, you have already completed your lab exam, and I hope that that went well and you guys aren't freaked out too much. So this is the review for specifically my section, which is CSE 1322 W01. And for that section, the final exam will be held between Monday, December 7th at 12:01 a.m., i.e., just a moment after midnight, all the way through December 8th, which is Tuesday, at 11:59 p.m. So basically, you have all day Monday and all day Tuesday to take the exam. You must start the exam sometime within that window, and you will have at least 2 hours to take the exam while you are inside of that window. So a couple of things about that. You will take the exam in Respondus Lockdown browser with webcam like you've done for test 1 and test 2. So exactly the same setup. You'll have to show your ID. Make sure you remember to bring your ID with you and make sure you have it handy, ready to go. Make sure you have nothing else with you when you're taking the exam and you're in a room where your laptop is plugged in so that you don't run out of battery midway through, where you don't have anybody coming in or out of the room for the couple of hours while you're taking the exam, and where you have a block of time that you are free. I would really, really recommend that you not leave it till the very, very last minute. A lot of you tend to start taking it at 11 p.m. on the night of the exam, and that's really not good because if you end up with any kind of a problem, you have no way to fix it. So I would really strongly recommend you try and take it a little bit before the end. With regard to the normal policies for the test, all the same things still apply as before. Respondus Lockdown browser, if you need to or you're on a new machine, you should definitely test that ahead of time with the test quiz that's posted in D2L. The webcam has to be facing you. Let me go through the rules on this real quick because a couple of you did get notes at the end of the last test that you got a 0 on your last test because the AI flagged you as not following the rules of the test. So very clearly, the rules are you must take the test in a brightly lit room. As you can see right now, I'm in a room where you can see my face and it's brightly lit. You cannot take it in a dark room where we can't see your face. You have to be facing the camera the entire time. We have to be able to see both of your ears in the camera to make sure that there is no earbuds in your ears. Which brings me to the point, you are not allowed to wear earbuds. You are not allowed to wear headphones or any form of audio equipment on your head. If you are caught with any of that, you will fail the class because we will give you a 0 on the test. You cannot be talking to anyone in the room. You cannot have a cell phone near you. You cannot have another laptop or computer near you. You can't have any notepads. You can't have any paper. You can't have anything with you. It is just you and the lockdown browser, and we have to be able to see your face the entire time. If something weird happens in the middle of the test, for example, a car crashes into your room or something like that, just tell us audio-wise, because we are listening to you, just tell us what just happened, and as long as it's nothing crazy, you'll be fine. So you don't have to freak out, just explain what happened to the video, and if something goes wrong, we will flag it and we'll review it and so on. Look, we're not looking to find problems, but we are trying to make a level playing field where everybody gets the same possibilities when taking the exam and has the same opportunities, and it's a fair and level test. So if you cheat, you will probably fail the class. Simple as that. We know that some people like to go and upload pictures of the questions and then pass them on to their buddies or tell other people in their group chat what's on here. You do that, you get caught, you will fail the class. So do what you want. Probably not a smart move, but there you go. Okay, well, that's enough about the logistics on there. Let me make sure I got everything. Yeah, you're not allowed to use your cell phone. You're not allowed to use anything else. Blah, blah, blah. Did I get all of that? I got all of that. Make sure your laptop is plugged in and you have good Wi-Fi while you're doing it. Okay, so those are the rules there. So again, to be 100% clear, Monday and Tuesday of next week, Eastern time, basically midnight to midnight, start of Monday, end of Tuesday. Must take the test. You need a 2-hour block in order to take it. All right, so that's the logistics. Let's talk a little bit about what's going to be on the test and what you need to study in order to do well on the test. So the first thing is, it is a cumulative final, so you are technically being tested over everything that we have taught throughout the semester. I can tell you, as it stands right now, there are about 10 questions. That could move because this is not a final version that I've seen, but you're probably looking at 10 questions and you'll be expected to write code on all 10 of them. So it is a cumulative final. You will have to do a lot of different stuff. All right, so we gave you a list of topics. This is posted in the D2L shell for our class, so you should be able to look through this, and it does list all of the topics that were in here. What I'm going to do today is I'm going to go through a couple of examples of things that are similar to questions that are on the test. I'm obviously not going to give you the exact questions from the test, but if you follow along with everything that I go over today, you will be in good shape for the test, insofar as if you understood the material that I give you today, while it is not the direct answer, you will be doing something similar to it on the test. Again, the test that I've seen as of today may not end up being the final one, and there's a possibility something new gets added. Technically, everything that you have learned for 1322 is in fair game. We could ask you any of that on the test, but I'm going to go over the things that you probably need to review if you are not overly familiar with them. So the first section here says review all the material from 1321. I would hope at this point that you know how to do basic addition and subtraction and incrementing and decrementing of variables, so I'm not going to cover any of that, at least not directly. The second thing on here is two-dimensional array coding, creating, and searching, which is definitely something you might want to review. All right, so I'm going to do just a very quick example over here. I will do it in both languages real quick, but basically what we're going to do is, first off, how do you define a two-dimensional array? So let's assume I want a two-dimensional array of integers. It's just going to be int, and then the array name, my array, and then, sorry, the square brackets go after the int. I think you can actually do it either way. Gets new int, and then we're going to do, let's say, a 3x3 array. Okay, so to be clear, when you're dealing with one-dimensional arrays, the indexes are 0 to whatever number you specify in that bracket. When you're dealing with two-dimensional arrays, the indexes are, you're going to put 2 indexes on there. The first index refers to the row, if you want to think about it logically, and the second index refers to the column. So you need to be thinking of like a matrix or a table, a cell that has some numbers in it. And what you're doing is you're moving around inside of those cells to do whatever it is that you're trying to do. Okay, so just to help you visualize this, this is what a two-dimensional array would look like. So I've made up just a little example here. We have 3 students, Bob, Jane, and Laura, and each of them took 3 quizzes, and I need to record their grades. So this is the two-dimensional array that we're going to create over in code. So Bob on quiz 1 got an 80, on quiz 2 got a 90, on quiz 3 got a 70. He was having a bad day. Jane got 100, 190, and Laura got 85, 92, 100. So assuming that we are just dealing with these, I'm ignoring the headers over here and over there. This is cell 00 in our array. And again, I just really probably should have filled in the background of those so that you understand that I'm saying these are not doobie-doobie-doo. There we go. All right. Did that work? Okay. All right. So we're pretending that that is cell 00. All right. So how do we fill that into our replit code? I'm just going to move that down so I can flip back and forth. So what I'm going to do is I'm going to say my array at position 0, 0 equals 80. My array at position 0, 1 equals, okay, so this is 0, 0 because 0 refers to the row and the second refers to the column. So 0, 1 is going to be this. That's Bob's second score. So that's a 90. And then my array at 0, 2 is 70 is what they got on the last one. Did I do something stupid? All right, so we're going to do this 3 times. Obviously, that's for Bob. And then we're going to have answers for, of course, that formatting is wonderful. Thank you. Could you just go away and leave me be? Oh, I see what the problem is. There we go. It's a two-dimensional array, and I only put in 1 dimension. That's why it's complaining. All right, and cell 1, cell 1, cell 1, and this will be for row 2, row 2, row 2. Okay, so to be clear, row 0 represents Bob. Row 1 represents Jane, and so that should be 100, 190. And then row 2 represents Laura, which is 85, 92, 100. 85, 92, and 100. Okay, So that's how you fill in a two-dimensional array. There are other methods. You can put the definitions directly on the line in curly braces at the time that you define the array. The things that you have to do in order to make a two-dimensional array: you must have a line where you declare that it is going to be a two-dimensional array. The fact that it's two-dimensional means there's going to be two sets of square brackets. You must then actually instantiate the array and allocate memory for it, and that's done with the new keyword, just like if you're creating a new object, and you will at that point specify the actual dimensions of the array. So new int 3, 3, and then you're going to fill in data into the array by accessing the individual parts. All right, if I needed to calculate the average of all of those grades across all of them, how would I do that? And the answer to that is I'm going to need a loop. So very specifically, I'm going to need a loop that's going to move through the rows, and then I'm also going to need a loop that moves through the columns. So I'm going to need a loop inside of a loop, because on row number 0, I'm going to need to look at column 0, column 1, column 2. And then on row 1, I'm going to need to look at column 0, column 1, column 2. So usually that's done with the two loops. So I'm going to say for int I equals 0, I less than 3, I plus plus. That's my outer loop. And then my inner loop, so that I is going to be the rows. And just to make it a little bit clearer, I'll go ahead and instead of using I will use row. Excuse me, row. All right, and then we're going to do for int column equals 0, column less than 3, column plus plus. Okay, and now I have two variables. So if I needed to, let's say, get the sum of all of the numbers, I would say int sum equals 0 to get started with, and then inside of my loop, I would simply say sum plus equals my array at position row column, because that's what I called my variables. And I might need to know how many I have, so I'm going to do count plus plus, and I'm just going to start off count as 0. And then after my loop, I'm going to calculate my average. So we'll do double average equals sum divided by count, and I'll print it out. And we will now find all the stupid places I forgot to put semicolons. System.out.println. Wait. I'm sure you're all staring at the same thing I'm staring at, thinking, how is he not seeing that? But I don't know what I'm not seeing. System.out.println. That looks completely reasonable to me. No suitable method found for print line. All right. Yeah, okay. Let's try making that a plus sign. Wow. Hey, look at that. Okay, average is 89. All right, so sorry about the dumb plus sign. The important things that you get out of this, and I can just tell you, you are going to have to define a two-dimensional array on the test. So make sure you understand the syntax of how to define a two-dimensional array, and then you will probably have to do something similar to calculating an average. In any time that you're dealing with a two-dimensional array, you'll need a loop inside of a loop. If you're dealing with a three-dimensional array, you'll need a loop inside of a loop inside of a loop. If you're dealing with a one-dimensional array, you just need a single loop. And that's simply because of each loop goes through one dimension. This outer loop does the rows, and the inner loop does the columns, and for every row, you have to do the entire column. So that's why the column loop is inside the row loop, because you're doing it for every single row as you go through. The details of what you're actually going to have to do in the test obviously will be slightly different, but you will have to do something similar to this. So make sure this all makes sense. You can come reproduce this yourself and test with it. Do a couple of other examples in your own head. Like this time I calculated the average. Maybe you might want to calculate the average for each row and print that out, or maybe you want to sort through the array and look for a particular grade, or find the highest or the lowest or the average, et cetera, et cetera. Those are all possible questions that you could have to do. But you definitely need to understand all of that. So that is dealing with two-dimensional arrays, coding, and creation. All right, so moving on from that, strings. So hopefully by now you guys know how to do a string. By the way, I'm not going to convert each of these into each language. I'll just flip back and forth between the languages. There is no difference in that code other than the print line if I were to copy it and bring it over. I'm just going to pause. I'll move it over and then I'll show it to you. Okay, there are actually some changes in C#, so let me just go through them real quick. Sorry. Two-dimensional array in C# is defined like that. You don't specify them as the individuals, as two separate things. You just put a comma between them. So there is that as a difference. And here we go. Okay. And now it works, and we get the same average. So life is good. Okay, so if you are a C# student, make sure you remember this syntax where you have commas. If you are a Java student, make sure you remember this syntax where you have square brackets. All right, so you might want to pause and review that if you're lost. All right, so next up we're going to talk about strings very briefly. So let me just define a new string. So this is Java. I'm going to call it my string. Actually, I tell you what, I'm just going to pause again and I'm going to start off in a new replit. Okay, so here we are back with two empty replit windows. So in Java, I'm going to say string, my string equals hello, hope you do well on final. We'll try to be grammatically correct. Okay, so what can you do with this string? Well, certainly you can print it out in your print line, my string, and that should happily print unless I did something stupid. Yes, I did. There's the semicolon. Okay. All right, and so the other things that you might want to be able to do, you might want to find the length of the string, and you would do that with my string.length. And we would call that size, and I'll go ahead and print that out as well. Probably shouldn't call it size. Come on, you can do it. Okay, string is 37 characters long. All right, you might also want to be able to find where something is inside of a string. So you could say my string dot index of comma, and that'll tell you where the first comma is in the string. And we'll do another. So that's going to tell you on what position in the string the first comma occurs, which should be 1, 2, 3, 4, 5. I believe it'll be position 6, give or take. Why is this so slow today? And what did I do, stupid? My string dot index of, I cannot find symbol my string. That's because there's not an R in there. I think my keyboard plots against me and it removes characters. All right. Okay, so it's at position 5, and that's because 0, 1, 2, 3, 4, 5 is where the comma is. And so you could certainly do stuff like that. There is substring, so if I wanted to get everything before the comma, I could say my string dot sub substring and then you give it a start position and an end position, and the start position could be 0 and the end position could be where the comma is. And that's never used, that's why that's complaining. And I think you get the general idea, and I'm missing a semicolon. Okay, so important that you understand index of, important that you understand substring, it's important that you understand length. There are other things that you could do, such as you could get to upper to lower, which will convert it to upper or lower case, and so on and so forth. What else is mentioned in here? I think those are most of the things that are useful. String concatenation, as you see, is just done with the plus sign. So that is that. All right, so again, I'm just going to pause and I'm going to move this over to C#. Okay, so this is the C# equivalent. The things that I had to change: capital letters on string. In C# it's lowercase, so everywhere you see string, change that. Length has a capital L instead of lowercase, and it is not a method, it is just an attribute, so it does not have parentheses at the end. Index of has a capital I for index, and everywhere it was system.out.println, I changed it to console writeline. Other than that, it's the same code and you get the same output. So that's the review of strings. Hopefully that helps. Okay, next up we have parameter passing and passing by value and passing by reference. So again, I'm just going to clear the windows and we'll start off there and do another example. Okay, so here we are back and we have an empty Java window here. And what I'm going to do is I'm going to create a new method. So public static, I will make this an int and I will call it do stuff because, you know, that's what we do. And it's going to take in an int, which I'm going to call x. All right, and I'm simply going to set x equals 7 up here, and down in my main method, I am going to call, I'm going to make a variable first. I'm going to call it int y, and I'm going to set it equal to 7, and then I'm going to call do stuff, and I'm going to pass it y. And before we do any of that, I'm just going to print y before and after the do stuff. All right, and you've seen this example before, but I want to go over it because it is one of those things that is confusing to people forever. All right, what are you complaining about? Must return a type int. Sure. There we go. Okay, so there are two ways in which you can pass information into a method. You can pass it by value or you can pass it by reference. If you pass it by value, then the method will get a brand new copy of the variable. All right. So up here in this method, I'm going to change it to x equals to 9, and I'm going to return x. So let's be clear. Down in main, I set y equal to 7. I print out y, and as you would expect, I get 7. I pass y up to do stuff, which passes a 7 up here. I change that to a 9, and then I come back down here and I print y again, and I get 7, not 9. Why is that? It's because the y variable that exists inside of main is completely separate from the x variable that is up here in do stuff. This variable, x, only comes into existence at the time do stuff is called. Anything I do to it up here only exists between those curly braces. As soon as the curly braces end, that x is discarded, it is thrown away forevermore, and when I continue on down here, nothing has changed in y. This is how passing by value works, and it is the default in both C# and in Java, that if I pass a variable into a method, it is passed by value. The method gets a copy of the value, and then it has its own local variable that it plays around with, and when that method ends, its local copy just goes away. Super important that you understand that. This is the exact same code. If I move it over to C#, it'll work exactly the same way. Okay, so now I'm going to do something different. I'm going to create a new class, which I'm going to call hidden.java. And over in hidden.java, I'm going to say public class hidden. And in here, I'm going to make a public variable. I'll call it z, and I'm going to set it equal to 7. All right, so down in my main method, I'm now going to make a an object of my class hidden. So I'm going to say hidden, my hidden equals new hidden. All right. Now, at this point, if I print out what is in my hidden, which is my object name, dot z, is that what I called it? I called it z, right? Yeah. Then I'm going to get a 7, just to make it so that there's some variation. I'm actually going to set it to 3, just so that we have something different going on than the other variables. So I would expect, and I'm just going to put in a comment here so I can see which is which. My object z variable has that value. Okay, so it should say object z and then should print out 3 because that is the value of that variable inside my object. All right, so I'm now going to make another method, which I'm going to call doStuff2, and I'm going to take in an object. hidParam, because that makes sense. And inside of here, I'm going to say hidParam dot z equals 12. All right. So I'm now going to call doStuff2, and I'm going to pass it my hidden. And then I'm going to repeat this print line that I had a moment ago, and I'm going to get the value of z. All right. Now remember, a moment ago when I did this do stuff down here, nothing changed to the variable that I passed into the method. Y was 9, or sorry, it was 7 when I started. I'm actually going to move this so that it's down inside the comments. So y was 7. I went and I called do stuff. Y was still 7. Nothing changed because what I passed was a value. However, if I pass a object, or if I pass by reference, which is there's a specific keyword in C# called ref, which will do the same thing, then in that case, what happens in the method actually affects the value in the main method. So, to be clear, missing return statement. Of course I am. The return truly does not matter for this, but there we go. I need to return, and there we go. Okay, so to be clear, over in hidden, I set this z variable to 3. This z variable is inside of the hidden class. It is not a static variable, it is an object variable. I instantiated my object, and I called it my hidden, and I printed out my hidden.z, which I'm welcome to do because I declared it as a public variable. So it is accessible to the object. So when I print that out, I got 3, which is not terribly surprising because that's what I set it to just seconds before that. I then passed that object to doStuff2, which took in a parameter of type hidden, which is my object name, and it modified that parameter .z to 12. But when I come back down here, note that it is now printing out 12 the second time that it prints out object z, because it has actually changed it. So, to review, under normal circumstances, when I make a call to a method, a copy of the variable is sent to the method. That is true unless what you're sending to the method is an object, in which case you are technically still sending that, but the detail of that doesn't matter. What you're actually sending is the object. And so anything that you change in the object has effects in the real world. It is passed by reference. I'm passing a reference to the entire object, and so when I modify things inside the object, either directly or indirectly, that will have an effect later on down here because the object is separate. It's off to the side of my main program. So I want you to think of it as, here's your main program, as I try to figure out where the camera is. Main program is here, and it has a variable, and over here is my object, and it may have variables. And if I pass the object into a method, anything that I change in that object is also going to be visible when I come back to the main method. All right, and it doesn't matter whether I do it directly. This is by me calling the variable that I made public and directly modifying it. I could also in here have I could have a method, like a setter method, that public void set z, and it could just change z equals 14. And then out here, I can just call set z, and that will have the same effect. I didn't actually take anything in, did I? No, I didn't. It would have been very helpful if I put parentheses after that. Okay, so that will set it to 15 this time around, and it doesn't matter that I'm doing it as a method inside of the object or whether I'm directly modifying it in the object. In all cases, the object's variables exist separate and can be accessed by anybody who does that, who wants to access them. So I want that to be very, very clear. There are definitely going to be questions about this where you're going to pass variables around, and you need to understand the difference between when it's passed by value versus when it's passed by reference, which are the two options. In general, everything is passed by value, which means that the method gets a copy. The only time that that's really not true is either in C# if you use the keyword ref, or if you pass an object into the method, then things that are inside the object, which are encapsulated in the object, can be directly changed, and that has effects in the real world. So hopefully that makes a lot of sense, and that is the difference between passing by value and passing by reference. If it doesn't make sense, you should probably reach out and ask. And just in case my C# people feel that I have forgotten them, I have not. Here is the equivalent code in C#. All I did was I just moved these over. I actually didn't change any of the code other than changing the print lines into console write lines. So it is literally identical with the exception of the call to the print statement. But you can see the same thing happens here. I still get 3 and 15 because, again, this is an object, and the object has a variable inside of it, which is called z, and it is a public variable, and therefore anywhere it is changed, regardless of whether it's in the main method or in any other method, has an effect and actually changes the value. So again, hopefully that makes sense. All right, so next up we are going to talk about class definitions with regard to fields, class variables, constructors, getters, setters, and all of that fun stuff. So for this one, I thought that I might actually knock out the abstract classes and interfaces in the same one. And what I'm going to do is I'm going to pull up the final exam that's posted on the FYE site from spring of last year. And I'm just going to go through that one because these, as you have probably noticed, tend to be very similar questions because there's only so many ways that we can ask this question, quite frankly. So we're going to grab this final exam here. And I think it's question number 6. Is that right? Well, let's just scroll. Question number 6. There we go. Okay, let's review abstract classes and interfaces and what the differences are between them. You did this on the last test, so hopefully this is relatively fresh in your mind. When you declare a class, you either specify all of the methods that you are going to have in that class and you actually code all of them, in which case it is called a concrete class because it is actually instantiable, meaning that you can make objects of that class. That is a concrete class. Nothing in there was abstract, nothing in there was an interface, it is concrete. If you decide that you are not going to implement at least one method and you mark that one method as abstract, then that entire class is now considered to be abstract. And then at that point, you can no longer make objects of that class because there's a part of it that hasn't been defined. You've stated that in order to make these types of objects, you're going to eventually have to do an instantiation or a definition of them, which means you're going to actually have to write the method, but it's not there today, so you can't directly instantiate the object. And so the usual examples of that are you're going to create a class that is for animals, and this is kind of what's happening here. And you know that animals are going to walk, but the way that an animal walks varies if it's a cat versus if it's a kangaroo. I actually don't know if kangaroos walk, but we're going with it. So some have 2 legs, some have 4 legs, some theoretically could have 1 leg. Some dogs have 3 legs. So the way that you walk might be different. It is a definitive fact that all animals are able to walk, said he, carefully thinking that there isn't an exception to that. But I don't think there's an exception to that. So The abstract class for animal is going to have a definition for walk, but the details of how you will walk are not always the same. So when you write the abstract class for animal, you can't instantiate an animal. That doesn't make sense. You have to instantiate cats or dogs or kangaroos or bears or tigers, oh my, but you can't instantiate animal because that doesn't mean anything. So animal says there will be a method for walking, there will be a method for barking or talking or moaning or whatever it is that the animal does, there'll be a method for eating, there will be a method for pooing and all the other fun things that animals do. So each of those methods would be declared abstract, meaning somebody somewhere is going to have to define how that works because all animals do these things, but the details of how they're done varies from animal to animal. So that's an abstract class. When you go to write the concrete class for a cat or a dog or a bear or a tiger, at that point you're going to inherit from the abstract class and you are going to implement each of the methods that is listed as abstract. If you are going to make a class that is actually instantiable as an object, then you must define non-abstract, meaning concrete methods for every method that is in the abstract class. All right, so an abstract class has at least one abstract method. The moment you made a method abstract, the entire class is abstract because you can no longer instantiate it. In order to make a concrete class, you must actually define each of the methods and give a concrete example of how walking and talking and pooing and all the other things work. All right, so that's the difference between an abstract class and a concrete class. In both Java and C#, you can only inherit from one abstract class. As a matter of fact, you can only inherit from one class, period. So if you are inheriting, there can only be one. The other alternative is you can create an interface. An interface can have all abstract methods. As a matter of fact, it has to have all abstract methods. It is impossible to define a method in an interface. You must give abstract. And then when you go to implement an interface, you will then have to actually go through and write a concrete method for every single one of the interface methods. And so in Java and C#, both languages, you are possible to implement as many interfaces as you want. So you can implement as many interfaces, but you can only inherit from one class when you are writing a new class. It is possible, although this is getting into the weeds, it is possible to make an abstract class from an interface. So you could implement an interface and still end up with an abstract class because you may choose not to implement everything in there, but at that point nobody can instantiate you. So you could have a concrete class that inherits from an abstract class that implements an interface. And there could be many, many layers of that depending on how many different interfaces and how many different classes you are ultimately trying to implement. All right, so you cannot instantiate either an abstract class or an interface. Both of those are impossible. So in the last test, there was a set of questions and it had a bunch of, telephone, my telephone gets new telephone. Telephone, my telephone gets new cordless phone, and so on and so on and so on. And you had to decide which of those were possible. If the thing that you are doing new on is an interface or an abstract class, it absolutely cannot work. You cannot call new on an interface or an abstract class because you cannot instantiate either of them. Polymorphism happens when the item that's on the left-hand side of that equals, so in this case we have animal and cat is what we're going to be doing in this example here. So once you have an animal, you may inherit animal and create cat. You can say animal, my cat gets new cat, and that's perfectly fine. That is polymorphism because the type and the new are not a match. It only works if the new part, the cat, is a child of animal from the standpoint of inheritance. So to put it a different way, animal must be the parent of cat in order for you to be able to say animal, my cat gets new cat. You can say animal, my cat gets new animal if animal was instantiable, which it's not because in this case we're doing it as an abstract. You can say animal, my cat gets new cat because cat is a concrete class, so that's allowed, and cat inherited from animal, so that's allowed. All right, hopefully that makes sense, and that's the inheritance and all of that fun stuff. So over here, we are supposed to write an abstract class animal that contains at least 2 attributes, name and is domestic. In every test, we are going to give you something that is similar to this. So you're going to have to write some form of an abstract class, some form of an interface, some form of a concrete class that inherits from one or both of those. And in each case, there will be some number of attributes and some number of methods that you're going to have to implement. So I'm going to pause real quick. I'm going to clean 2 windows, and then we're going to start on this guy. Okay, so we are going to go ahead and implement this. I created a blank replit, and then I just added an animal and a cat.java. So the animal is going to be the abstract class. So let's look at the question. So write an abstract class animal. Public abstract class animal. All right. A number of you in the questions have done that, which is not right. It's not a method. You're writing a class. Classes do not have parentheses at the end of the line. So this is the definition of an abstract class animal. It contains at least 2 attributes, name and is domestic. So string name, Boolean is domestic. All right. And a abstract method, animal details, that will assign values to the corresponding object's attributes. Okay, that is badly written, but I wasn't here, don't blame me. Abstract animal details is going to be a method. It looks like that method is going to be abstract, so I'm going to say public abstract, what is it called, animal, the return is going to be void, it looks like, animal details. Okay, this one does get parentheses at the end because it is a method. It is not a class. This is an abstract method, so I'm not going to put a body in there. I'm just going to put in a semicolon. So life should be good. That should compile at this point. And that is the definition of the abstract class animal. It is basically saying anyone who implements animal has to implement animal details. But how that works, that's up to the class that inherits animal. Let me just make sure that there isn't anything there. Write a concrete class cat that contains its own attribute, favorite food, and inherits from the animal class. All right, so this is going to be public class cat, and it is going to extend animal and extends. All right, it's supposed to have, what was it called? Favorite food, we'll call it a string. And we'll set it equal to, I don't know, cat food. I have no imagination today, sorry. All right, and then it inherits from the animal class. Okay, something else I've seen a lot of you do is you take the variables name and is domestic and you go ahead and you put them back into class cat. You don't have to do that. You inherit it. Because you extended animal, you automatically get all of the values and all of the methods that are in animal, as long as they are public or protected, which is probably something I should have written here. So inherently, cat automatically has access to name, and it has access to is domestic, and it has access to animal detail because you are extending animal. So you don't need to redefine them here. As a matter of fact, you shouldn't redefine them here. All right. So then it says, if I compile this right now, it's not going to actually error on anything, because even though I've extended the class, yes, okay, it is going to error on this, sorry. Because it's an abstract class that I extended, I have to implement animal details, of course, because we declared that as a method that was abstract. So let's go ahead and do that. So generally when you're actually writing the concrete one, the right answer is just copy and paste. Obviously remove the word abstract because you're not going to do that. And instead of the semicolon at the end of the line, you're going to put in the actual parentheses and you're going to write whatever it is that you're supposed to write. Implement animal details method that just displays the animal's own and inherited attributes. Okay. So I'm supposed to say name is, and then plus name, Now you might say, well, where's name? It's not here in this cat, but it is in the animal that I am coming from. And name is name, is domestic, is domestic, and favorite food is, and that is a local variable that I have from down here. Now, if I run this right now, it'll compile because I have done what I said I would do, which is I've implemented the abstract method from the class, but it actually does nothing because, of course, I've not actually called anything yet. All right, so the last part of this was, and a main method that creates an object of the class, of the cat class, assigns values to its attributes and displays them to the console. Okay, so over here in main, I'm going to say cat, my cat equals new cat. And then I'm going to say my cat dot animal details is the name of the method that I did. And so when I call that, that's going to print it out. Now the problem is I didn't actually assign any values to anything. I'm calling the default constructor here. And so what I got is name is null, is domestic is false because the default for booleans is false, and favorite food is cat food. And the reason that favorite food is cat food is because in that one I did actually assign it. But if I want to be able to create a new cat, it would sure be nice if I actually had a constructor. So I'm going to say public cat, and the way you make a constructor is you just define a method that is the same name as the class, and it takes in whatever parameters you want. So string, I'll do name, and string, boolean is domestic. All right, and in here I'm going to say this dot name equals name, and this dot is domestic equals is domestic. All right, and the reason for the keyword this is because I called the parameter that I took into the constructor, I called it name, but the variable that is up in animal is also called name. So there are two things called name, and it's not clear which one I'm talking about. So this refers to this object's version of name is getting assigned name, which is the local variable here. So that refers to this, and this dot name refers to the object variable. So now, if I come back up to main, when I create my cat, I should be able to say Fluffy, and Fluffy is not domesticated, so false will come in there because Fluffy's a bad cat. All right, and so now my print details should actually print out Fluffy's name, and they are not domesticated, and their favorite food is cat food because they're the most boring cat in the world. All right, so hopefully that makes sense. So let's review the things that I covered there. The first is a constructor. If you're going to build a constructor, the constructor should be the same name as the class. It should take in parameters. If you're overriding the constructor with, overloading, don't say the bad word. If you are overloading the constructor with more parameters, then whatever parameters you need come in. If you name them the same thing, you're going to need this keyword. If you don't name them the same thing, you could have avoided that. So if I just call this new name and new is domestic, I should probably not do capital letters on those just to be nice and polite. Then I can simply say name gets new name, and is domestic gets new is domestic. And you can see that will work exactly the same way. It made no difference to the code, but I didn't have to use the this keyword. So the this keyword is there if you are referring to a variable of this object inside of it when you're writing the object. And it helps differentiate from a local variable. That's really the only reason for using this. That's how you make a constructor. This is also a setter because I am setting some variables in here that are in the object. Please note, the variables that I'm setting, name and is domestic, are not anywhere defined inside of cat. They are defined inside of animal, which I am extending, and therefore I am able to access them directly because they are public. Had I set these as private, then all of a sudden this code will cause an error because I am trying to set a variable that I do not have access to. It is not possible for me to set name to a value inside of cat. Even though I'm extending animal, the fact that it is private means I don't have access to it. So it is only available to me as long as it is public or protected? Goodness, cannot spell today. If it's protected, I should be fine and I should still be able to do it. So public and protected means all of its children are able to change it. Children being people who are inheriting from this particular class. Private means it is private and it is only to this class. It doesn't make any sense to have a private variable inside of an abstract class. Usually, if you're having a private variable, okay, that's not true. Scratch that last 10 seconds. There are reasons to have private variables inside of classes, even abstract classes, but you cannot directly change them. You would have to change them through setters that you would then have to provide publicly from the class. If you don't have setters and you mark it private, there is no point to it because nothing can actually change it. So there you go. All right. Hopefully that makes sense. Hopefully you know the difference between public, private, and protected. Those are going to be important things on the test. Public, protected means that anyone who inherits from you will be able to change it, or anyone who instantiates you, in the case of public, will be able to change it. Private means no one can change it except for methods inside of your own class. An abstract class is any class that has a method that is abstract. As soon as you have one method that's abstract, the whole class is abstract. You cannot instantiate abstract classes. You can instantiate concrete classes, of course, because those are ones that everything has been actually defined in. Animal is abstract. Even if I didn't put the word abstract up here, it is still abstract because the fact that there is one abstract method in there means that that entire class is now abstract. So if I had tried to do it, it would have errored. And as a matter of fact, there you are. Animal is not abstract and does not override abstract method animal detail. So that is an abstract class. Yeah, I think that's really it about abstract classes and the difference between public, private, and protected, and key classes. Interfaces. We should talk about interfaces next. Let me convert this code over to C#. I'm just going to pause and do it so you don't have to watch me type, and then we'll move on to interfaces real quick. Okay, so here is the completed C# code. I just moved it over. There were only a couple of things that had to be changed. String lowercase, bool instead of boolean. Extends becomes a colon. When you're doing the extends keyword, it becomes colon. And console.writeLine here, and down in the bottom console.writeLine, and the string and booleans here. There's one more thing that did have to be changed, and it is actually an important detail. C# is very picky about this, whereas Java was a little bit more forgiving, and that's probably bad because it encouraged me to do something stupid. Over in Java, when I overrode, so let's again talk about the public abstract animal details. In cat, when I wrote the definition of animal details, I didn't specify that I was overwriting, which I really should have. C# actually errored and forced me to put in the word overwrite. Without that keyword in there, when I tried to compile it, I get an error that says you are making a current override, and if you meant to do that, you need to put in the word override. So now it's in both, and you can see that the C# code works. You can see the URL up there. You can obviously pause and come back to this code at any time, but that's the C# version of it, and that is the Java version of it, and it still works even when I put in the @override. Okay, so that is the two of those. I'm going to clear my windows and come back in a second. Okay, I actually changed my mind. I'm going to leave it inside of here. I'm just going to add in an interface to this example. So we're still in the animal and the cat example. So what I'm going to do here is I am going to create an interface called iWalkable. So an interface gets defined very similarly, but you start off with the word interface, and I'm going to have a single method called walk, which I'm going to say has to be implemented. So now that I have that, this will compile without any issues because I haven't used it anywhere. But if I come into cat and I say that the cat not only extends animal, but it also implements iWalkable, then all of a sudden I'm going to get an error. The reason I'm getting an error is because iWalkable defines that anyone who implements that interface must implement a method called walk, and that's not in here anywhere, so the abstract method walk is not overridden. So therefore in my cat, what I'm going to do is I'm going to say public walk, and I don't know, All right, and so it does something stupid. The only important part is that I am overriding the method walk. If I do not override the method walk, I will get an error because I said anybody who implements that interface has to override, and then I didn't override, and so that's obviously an issue. So method declaration return required. Yes, that's because it's a void. All right, so the important part here is an interface cannot have any concrete methods. They are all abstract. Inherently, I wish inherently was not the word I used there. If you are creating an interface, all methods that you specify in that interface are going to be abstract because you cannot put concrete methods into an interface. In a abstract method, you absolutely can have a mix of concrete methods and non-concrete methods. For example, I can quite happily here in the animal abstract class say public void do stuff, and I can have x equals 7, and that is all perfectly valid as long as I do that. It'll all still compile, and now there is a concrete method and an abstract method inside the abstract class. That's perfectly valid. If I try to take that same public do stuff and move it over to iWalkable, I will get an error because you cannot do that in an interface. So interfaces, all abstract methods, you're just specifying these are the things people will have to implement. Abstract methods can have a mixture of concrete and abstract methods, but as long as there's one abstract method, the entire class is abstract. Concrete methods, concrete classes, are allowed to extend or inherit one class and implement an unlimited number of interfaces. All right, so I'm going to go ahead and move this over to C# just so you get the same thing over there. I'll actually do this one live because it's actually very, very simple. Nothing really should change. So I'm going to grab this. I'm going to put that in here, interface iWalkable, and then in cat, the only thing that was different there was when I created it, I said extends animal in C#, and now iWalkable, which is the interface. And then I need to actually implement an override for walk, which is not worth copying. Public override void walk. All right, and that should now work, and everything should be hunky-dory, except it doesn't. It's marked as override, but no suitable has been found. Did I not put that inside of cat? I did put it inside of cat, and it is called walk. And what did I do stupidly? Is marked as an override. Oh, right, you don't specify override in C# when you're implementing interface methods, because it doesn't consider it an override. All right. So that is the example of interfaces and abstract classes. We've talked about public, private, protected. We have talked about the this keyword. I haven't mentioned the super keyword, but the super keyword is when you're trying to call a method that is in your parent that is not public. And yeah, I think that is everything to talk about abstract classes and interfaces and whatnot. Difference between overloading and overriding. Let's go through that again real quick. If you have a parent and the parent has a method and you are implementing or inheriting from that parent and you wish to have another version of that method, then you would override the method from the parent. In the case of an override, there will be the same number of parameters in the parent as there are in the child. If you are overloading a method, typically happens within a class, and you may have more than one way that you want to call it. For example, if you're adding numbers together, you might want a version of add that takes in 2 numbers, and a version of add that takes in 3 numbers, and a version of add that takes in 4 numbers. So you would have one version of add, 2 numbers, int x, int y. You might have another version of add, int x, int y, and int z, and another version of add, int x, int y, int z, int a. And those are overloads because you are overloading the method to give it multiple different ways. So those are the key differences there. All right. Okay, next up, everybody's favorite topic, we're going to talk about recursion. Hopefully Hopefully you remember this one from earlier in the semester. All right, when we have recursion, we are going to have a method that is going to do recursive calls. So what I'm going to do is I'm going to do power. So to remind you, if you're calculating something to the something to power, so like if I say 4 to the second power, that is equivalent to me saying 4 times 4. If I were to say 4 to the third power, then that's equivalent to me saying 4 times 4 times 4. So that is how you do power. So I'm going to stick those in comments up the top just because that's a useful way of looking at that. And again, you are going to be asked to write a recursive method on the final exam, so you definitely need to understand recursion. So public, we are going to return, I guess, an int, and this is going to be power, and it's going to take in x and y. So we'll call them something better, base and power. And here we go. All right. Every recursion message must return type. Public int. What? Must return. Yes, I know I haven't written it yet. Stop yelling at me. Okay, so every recursive method must have two things. The first thing is it must have a base condition. The base condition is what is going to stop the recursion. And so you need to think about whatever it is that you're implementing and figure out what the most simplest answer is. And the simplest answer in the case of power is going to be if somebody asks you to calculate something to the first power. 4 to the first power is just equal to 4. So to write that into code, if power equals 1, then we are going to return, I hope it's happy now, base. Okay, that's not exactly right, but we're going to come back to that in a moment. If that is not the case, then we are going to need the second part of recursion, which is the recursive call. It is very important that the recursive call gets us one step closer to calculating our final answer. So how are we going to get one step closer here? So the answer is we need to take whatever is given to us and we need to multiply that base by itself one less time. So I'm going to do that up here, and I'm just going to explain in what I mean by that. So I'm going to say 4 to the 5th. What is that equal to? Well, it's obviously equal to 4 times 4 times 4 times 4. That is 4 to the 5th. However, another way of writing that is it is the same as 4 times 4 to the 4th, right? Because 4 times 4 to the 4th is the same as 4 times 4 to the 3rd, which is the same as 4 times 4 squared, which is the same as 4. And you can see if you go down the chart and you keep answering it back, then you will get your answer. So what I'm going to return is base, which is this first 4, times power of base and power minus 1, because I have to be moving 1 closer to the answer. When I eventually get to 1, it's going to return base, and so therefore I know that that's going to return 4 in this case. So I'm going to call my function, and I'm going to call it with 4, and let's do 2 first, and I'm going to just give myself a variable for that, and I'm going to print it out. Just so that I can see what's going on. All right, what are you complaining about? Cannot make a static reference to a public static. Okay, so let's run it, and with any bit of luck, that's going to return 16 because 4 times 4 is 16. All right, so to be clear, let's step through what happened here. When I called it with 4 and 2, base was assigned the value 4, and power was assigned the value 2. It came in and said, is power equal to 1? It is not. So it skipped over that, and it made a recursive call. The recursive call would have said, eventually it's going to return 4 times, but it first must make a recursive call to power, passing it 4, and now 2 minus 1, which is 1. So in that new version of the code, it came in with a 4 and a 1. Power is equal to 1, 1 is equal to 1, so that's true, so it returned 4. So we now know that the recursive call evaluated to the number 4, which in the previous version was supposed to return 4 times the return value, which is 4 times 4, which gave me 16. And as a result, I got back 16. So I'm going to call it with 4 to the third. And we're going to see, oh goodness, I lost the parentheses somehow. We're going to see that that's going to be 4 times 4, which is 16 times 4, which is 6, 4 is 24, 64. Yeah, there we go. And so on and so forth. Okay, so what do you need to get out of this little example? The first thing is, anytime that you write a recursive function, which you will have to do on the final exam, it will not be power, but it'll be something very similar to power. You are going to need to have a base condition. If you do not have a base condition, it is not going to work. The base condition has to be the simplest case, and it has to actually return a number, not make a recursive call. There might be more than one thing in the base condition. You might have if power is equal to 1 or base is equal to 7, or there may be other complications in there depending on what you're trying to calculate, but there will have to be a base condition that can hit. Then, after the base condition, assuming that it didn't hit, there must be a recursive call. And the recursive call must call the function that you are writing, which is what I'm doing here. The function I'm writing is called power, and I'm calling power. And it must pass in something that is moving you closer to the base condition. If you're not getting closer to the base condition, it ain't going to work. So super important that you pass in something that's getting you closer to the base condition. And that's it. That's all there is to recursion. You must have a base condition. You must be moving closer to the base condition with your recursive call. As long as you do those two things, you should be good. You guys have had to do this in labs. I think you have to do it with folding paper for V's and W's in a lab, and you've had to do it with other things. The actual details of what you're doing are not what's important. What I need you to make sure is that you know how to write a recursive function. And again, on the final exam, you will have to do one. It won't be power, but it'll be something pretty similar to power. So make sure you understand that. This code would translate directly over to C#. I am 99% sure, but I'll go ahead and do it. Okay, well, that one was amusing. I said that it would translate exactly to C#, and it totally did not. And there is a couple of reasons. First off, the word base is a keyword in C#. So calling something base as a variable name made the compiler very unhappy. So I had to change it to my base. The second thing is that the word power turns out to be a keyword in C#, so I could not call my function or my method power, so all the variables and all the method names all had to be changed, and then once I did that, it compiled correctly. So that's the C# version of the code. You guys are welcome to grab the URL up there from pausing your video. It is identical code, I just had to change around to all of the names of the variables, so just be a little bit more careful with your variable name. Calling things base was probably not a good plan. All right, so that is that. Okay, so chugging through our list of things in here, we have covered overloading and overwriting. We've talked about polymorphism and which things can be instantiated. We are not going to talk about GUIs because there are no questions on the final exam about GUIs or graphics. The only possible thing that you might get asked is something about like the coordinate system of where that is, but we're not going to ask you to write any code. Just remember that the coordinate system for 0, 0 is in the top left corner of the screen. That's about all you need to remember about graphics. Other than that, you can flush all of that out of your head. Recursion we just talked about, and so now we're going to move on and we're going to talk about these things down here, which are linked lists, stacks, queues, exception handling, threading, and I/O operations. So we're getting there. I know this is a long lecture. I'm trying to be fast. All right, I'm going to do stacks and queues first, and then I'll come back to linked lists. So let's remember what a stack and a queue is. So we're going to start with a queue. All right, so a queue, I want you to think about people that are in line at a grocery store, and his artistic abilities are amazing. As you can tell, these are hyper-realistic people, and here's our fabulous cashier at the local Publix. All right, so that's meant to be the conveyor belt where they put the groceries. All right, as you know in a queue, the first person who gets into the queue is the first person who gets processed and gets out of the queue. So first in is also first out. First in, first out, FIFO, that's what you need to remember for queues. Honestly, don't remember that. Just remember that it's like a grocery store. First person who comes up is the first person who gets processed. It's called a queue. I have an advantage. I was born in Ireland, and in Ireland we actually call it a queue. Here you say standing in line because that's shorter. Anyway, so a queue, line of people, that's what you need to remember. If I give you a set of numbers and I tell you to put them into a queue, what I want you to think about is I'm going to give you the numbers 1 through 5. All right, so I'm going to say I want you to in queue 1. So I want you to think about putting a 1 there. Then I want you to in queue 2. Then I want you to in queue 3, in queue 4, in queue 5. And now I want you to dequeue. Then I'm going to get the first person out. DQ the second person, then DQ the third, then DQ, then DQ. All right, so let's take an example of this. So I'm going to clear the frame, or maybe not. There we go. So we are going to push, which is the word that you normally get, the number 1 into the queue. So I want you to think about it as being there. And then you're going to push 2, and that's going to put it here. Remember that you're pulling from this side in a queue. All right, so we're going to push 3, and that puts it there. All right, so that's a queue. When I say pop, I am going to get back the value 1 because that's the first thing in the queue. And that is no longer in the queue when I call pop. So to be clear, in a queue, there's usually front as a method which will tell you what's at the front of the queue, and then there's pop, which will actually take it out of the queue. So in reality, I would have done front, and that would have been assigned to X, which is now my X is going to be 1. All right, and then I would pop, which just has the effect of taking it out of the queue. All right, so this is a queue. The numbers go in the furthest, the first number that gets pushed in, the first number that gets pushed into the queue ends up at the front of the queue, and then everyone gets into queue behind them. And again, as long as you think about the grocery store and going to checkout, your life will be fine and you will always remember how a queue works. All right, the other alternative is a stack. And for this, I need you to think of pancakes. And of course, pancakes always sit on a plate. Again, my drawing skills, just amazing. That's the butter, and lots of syrup, because that's important as well. Here's the big plate that they're all sitting on, and Abstract Art 101 has been completed. All right, the deal with a stack is when you make the pancakes, you will put the first pancake on the plate. The next pancake will get put on top of it, and then the next pancake will get put on top of it. When you eat the pancakes, unless you are a barbarian, you start at the top of the pancakes and you eat that one, and then you work your way down to the next one and then the next one. So it is not like a queue, because in a queue, it was first in, first out. But in the case of a stack, it is last in, first out. So it is LIFO. So again, stacks, you get a stack of pancakes. I think everyone in the world can agree that stacks of pancakes are how stacks should be visualized, because everybody calls them a stack of pancakes. All right, so if I gave you those same 5 numbers, instead of drawing them the way that I did before, what I want you to do is I want you to picture them as a vertical line like this. So when I tell you to push 1, that's going to go down here. When I tell you to push 2, it's going to go on top of it. If I then tell you to pop or do top, which tells me what's in there, it is going to take out this one. So you're going to get a 2. All right, so let's take an example of both of those together. I'm going to push into Q 1, then 2, then I'm going to pop from the queue, and I'm going to push that into a stack. I'm going to pause so that you're not watching me write, and I'm going to write down what we're going to do, and then we're just going to do it. Okay, through the magic of pause, we now have something that we are going to do. So we're going to do a queue. So I want you to in-queue the number 1. Now I want you to in-queue the number 2, and now I want you to in-queue the number 3. Now it asks for front. Okay, so the front is going to be this. Okay, so we now have a variable called x, and it is equal to 1, because that's what's in the front. The queue itself didn't actually change when I did that, because front doesn't actually take anything out of the queue. So everything is still the same in the queue. All right, moving on to the next line, it says that we are supposed to dequeue. That's going to have the effect of that guy popping out, and that's no longer there. All right, now we're going to in-queue 4, which means it goes at the back of the queue. That was that line. And now we're going to, y is going to be equal to the front, which is the number 2. we're going to dequeue, which has the effect of that guy coming away. We're going to dequeue, which has the effect of that guy coming away. And we're going to set z equal to the front, which is the number 4. And now we're going to print out x, y, and z, which gives me 1, 2, 4. All right? The numbers are not important. What matters is that you understand how I did this, that new items are added on one side. Sorry, that was a terrible thing to do. I drew that in exactly the wrong place. New numbers are added to the back of the queue, and when you are ready to process somebody, you pull them from the front of the queue, just like in a grocery store. I will tell you that the word in queue is sometimes written as push, even in queues. The word dequeue is sometimes written as pop, even in queues. And front is sometimes written as peak, because that all makes sense. So just words. Push and in queue, pop, dequeue, peak, front, top, all pretty much synonymous for each other. So that's an example with a queue. If you were asked to do that, you would have printed out 1, 2, and 4. We're going to do another example, this time with the stack. As I said, the moment they tell you stack, I need you to draw a U. And then what they told me to do was push the number 1. Then they told me to push the number 2. That's that line. Then they told me to push the number 3. That's that line. Okay. Now x is going to get peak. So x is going to be equal to the thing on the top of the queue, which is the number 3. I said queue. I'd like to rewind that 10 seconds. Peak is asking for the number on the top of the stack. So I take a look at the top of the stack. I got 3 and x is equal to 3. So that's that line right there. Next thing that is supposed to happen is I'm supposed to pop. That takes that guy off, and that was that line. Next thing is I'm setting y equal to peak, which is going to be the number on the top, and that's going to be the number 2. That was that line. Now I'm going to push 4, so it goes onto the stack as a 4. That was that line. I'm going to pop, which has the effect of that guy coming off, and that was that line. I'm going to push a 5. I need a bigger stack. And then I'm going to push a 6. And then I'm going to peak, z equals 6. And again, that gives me a print statement where I will print 3, 2, 6. In this particular case, the numbers are not what matters. It's the process of how I did it. When you have a stack, you need to visualize it like that. You push numbers in, they go on the bottom, and they work their way up the stack. When you peak or take something off, it always happens at the top of the stack, which is the opposite from what's happening when you were dealing with queues. Over in the queue world, everything that we were doing over there, when new numbers came in, they go into the back of the line. When people come out, they come off the front of the line. All right. And other than that, in queue versus push, same difference. Dequeue versus pop, same difference. Peak, front, top, all those words mean the same thing. They're just returning the value that is next to be processed. In the case of a queue, the next to be processed is at the front. In the case of a stack, the next to be processed is on the top. So that's the explanation of queues and stacks, and that's pretty much what you would be asked to do on the final exam, is something along those lines where you might need to understand how to move numbers in and out of a queue or a stack and or a queue and stack. You may have to pull from a stack and push into a queue or vice versa. So make sure you understand how that works. The code for implementing both of those that we showed you in that lecture, there is just a built-in library for both of them, and you simply call push and pop and enqueue and dequeue, depending on which one you're using. So that's as much as you need to know about queues and stacks. So next up, we are going to move on to linked lists. So let me clear and I'll get you. Let me clear my windows and then I will get you back to the point where we're in writing code for a linked list. All right, so we are back and we are going to talk next about linked lists. So with a linked list, what you hopefully remember, if we go back over to our little whiteboard here, a linked list is going to have effectively a reference that is pointed to the first node, and each of these is going to be called a node. The node is going to have some data in it, whatever that data may be, and it's also going to have a next, which is going to be a reference or a link to the next node in the list. So in order for this to work, we need to have a class called node that's going to have some information in it. So over in Java here, I'm going to start off and I'm going to say node.java, and I'm going to start creating public class node, And let's imagine that I'm going to make a linked list of, let's see, strings. So we're going to have string name. I'm going to put a bunch of names in there. Let's imagine. We should do that lowercase. And then I'm going to have a node called next. All right, and so that's a little bit self-referencing. I have this reference or this link that connects me to the next node. I'm calling it next, which is just to make it easier to think about. It is of type node, which is the very thing that I'm defining right now. That's the weirdness of this. All right, I'm going to go ahead and give myself a constructor as well so that I can actually assign values to that string. So I'm going to say public node, and I'm going to say string or new name, and I'm going to say name equals new name. All right, and that's pretty simple. So over here in my main method, I should simply be able to define a node, and I'm going to call it head, and it's going to get a new node. All right. When I create the node, I should probably set next equal to null every time that I do that. And that's super important because the null is how you're going to know that you've reached the end of the list. And so that's going to be important. These are both public. I'm noticing that as well while I'm staring at it. So public node next, and there we should be good on all of that. Did I do anything crazy there? I don't think I did. All right. So what I really wanted to do was I wanted to have enda being in there. Can it be applied to the given type? Yeah, because I said I was going to take in a string and I didn't give it a string, which was not very smart. All right, so making a new one, and that is going to have enda in it. Okay, great. So didn't really do anything, at least not visibly. If I want to add another entry in there, then I would have to decide, do I want to put that new entry at the beginning of the list, or do I want to put it at the end of the list? And so if we take a look here, if I currently have a link to enda, and I set the next equal to null, which is what I did, if I want to add in Jane into my list, then the question is, does it look like this, Jane, and then enda? Or does it look like this, enda, and then Jane? Those are two valid options, and either one of them is perfectly reasonable. I'm going to choose to do this one because it's just a little bit easier. So that's prepending it to the list. So what I'm going to say is I'm going to say node Jane equals new node. I'm going to put in Jane, and then I'm going to say what did I do? I said name, not Jane. Jane, goodness, Jane dot name. I don't know why I'm obsessed with the word name suddenly. Jane dot next equals head, and then head equals Jane. Okay, so that was just me connecting the various parts of the list. So I made a new node, and then I set the next link inside of Jane to point to wherever head was, which has the effect of pointing to enda. And then I set the head now pointed to Jane. So at this point, I could write a loop that would send me down the list and print out everybody that's in the list. So I would do that by saying while head is not equal to null, and then what I would want to do is print out the name in each of them. So I would say system.out.println, and what I'm printing is head.name, and then I would need to move head equals head.next so that it is moving along the list. Now, to be clear, this has a bug. And I'll explain the bug in just a moment, but it should print out for me Jane and then enda, because the order that I put them in is Jane and then enda. And then weirdly it'll say hello world because that comes per default. So I got Jane, I got enda. All right, so what's the bug? Well, the bug is if I try to take this and do it a second time for some strange reason, I'm And I'm just going to put a 1 in here just so that you can see definitively that that's coming from 1. And I'm going to put a 2 in here so you can see definitively that's coming from 2. What's really interesting is that I am going to get nothing the second time through, because what I actually did was I destroyed the list as I was going through it the first time. Every time that I did head equals head next, that has the effect of literally getting rid of head. So let me be clear, at the time that I built this, here was head, and it had Jane, and it had an X pointer that pointed to Enda, and Enda had an X pointer that pointed to null. What I said was, while head is not null, which it is not, then it's going to print head.name, which is that. So that's why it printed Jane. But then I said head equals head.next. So head.next is this. And what I did was I set head to that. And the moment that I did that, this is no longer accessible. There's no way to get to it. So when I asked for head.name, it printed out Enda, and then it said head to head.next. Well, head.next, if you follow head's pointer right now and you look for next, that's out here. So what it did was it changed head to point to there. And at that point, that node is no longer accessible. So that was a terrible way to do that. I just wanted to prove the point that walking through the list can be destructive if you are not careful. And so the way that you would fix that is you would generally say node temp equals head, and then everywhere that you said head here, you would use temp. And now all of a sudden, life will be good. This no longer has the bug, so I'm going to take away that statement. And okay, just to prove the point, I'm going to leave the second one in there, but I am now going to see 1 Jane, 1 Enda, 2 Jane, 2 Enda, and at that point the list is destroyed, but that's because I destroyed it the second time through, not the first time through. So you'll see that that works. All right, so that's a quick review of linked lists. The important thing that I need you to get out of a linked list is, how would you define the node class? The node class is nothing magical. The only thing that's weird or strange about a node class for a linked list is that you're going to have a attribute called next, which is going to be of type node. Other than that, there's nothing magical about this class. It just allows you to connect another node to another node to another node. That's the magical part. So if you were asked to define on the test a node class, you would need to make sure that you have whatever variables that you might be asked to put in, and that you also have that next node in order to be able to get down the list. If you look at test number 3 from last semester, question number 2 gave you an example question that you might want to flip through. I just did prepend, which is how you put a node at the beginning of the list. Append is how you would put a node at the end of the list. It might be worthwhile doing a quick refresher on how to do that. It works pretty much the same way, but based on the code that I gave you here tonight, you should be relatively easy for you to go back and make a linked list, putting the nodes at the end instead of putting it at the front. The little hint I will give you is that you're going to need to do something very similar to this with a temp pointer, and you're going to need to stop just before you get to the last node. When you get to that node, then you will add the new node after it. So hopefully that makes sense. So again, linked lists made up of a bunch of nodes that are connected to each other. The way that they're connected to each other is with a next. That next is how you get from the first one to the next one. There's nothing magical about the word next. It's just how they are connected. You put new nodes in at the front, or you take nodes out. You can also put new nodes in at the back and take nodes out at the back. You can do a print of the entire list, which is exactly that code. You could do a search through the list by just iterating through it and seeing if what you were looking for is in there. And that's pretty much it. Linked lists work very similarly to arrays, except that you don't have the index number where you can access an index in an array. So hopefully linked lists make sense to you. You can see that there was a question on the last test 3. And this final has at least one question about a linked list. If you understood everything I went through today, you should be in good shape for that. So let me see what's next. We did linked lists, we did queues, and we did stacks. So we're down to exception handling, file I/O, and parallel and threading. So we're going to start off with file I/O. So let me clear replets, and I'll be back in a second. Okay, so this topic is file IO, and I'm just going to cheat here, and I'm going to reuse the code that I have from a previous lecture just to save me typing and also to speed things up a little bit. What you need to know about file IO is that you need to know how to open a file. You need to know how to read lines in from a file. You probably need to know how to write lines out to a file and how to close the file. All right, so if you look at the example that's on the screen, this one is from earlier in the semester. It's actually from whatever lecture that was. The parts that are highlighted are how you open a file. This is Java, and so it's specifying that it's going to be a file. You give it a name, you say new file, and you give it the file name, which the file name has to be where it is on the file system that you're trying to open. And then you probably are going to use scanner to read lines in from the file, while the read file.has next line, then get next line, and that gives you a string, and then you can do whatever it is that you want to do with the string, and then you can close the file at the end. That's the important part of file IO. The rest of what's happening in here was just me doing a particular example, but if you definitely need to know how to open a file, how to read and write to the file, and how to close the file. You will notice that all of that is in a try-catch in Java, and that's very important. You actually cannot do it without a try-catch. So you need to be catching file not found exception, or at least just catch exception so that you have some way of catching anything that comes from that. So anytime you're doing a file IO, you're going to need to do a try around it and do a catch after it. So again, to review, in Java, you need to make sure you understood those lines. The equivalent lines for C#, likewise, you're going to have a try, and things look fairly similar. The C# code is just a little bit simpler. You're going to use stream reader, and then you're saying while not end of stream, read line off of that. And if you know how to do that, that gives you a string, and then at that point you can do whatever it is you're trying to do with the string. You call close at the end in both cases. That's important to close out the file, and you need a catch for your file not found exception, the same as we had in Java. So again, to review, for file IO, definitely need to know how to read in a file, definitely need to know how to write out to a file, both of which are in this example. And so hopefully that gives you everything that you need to know. So that's all I'm going to tell you about file IO. You can pause the video and go back and look at those two URLs if you need to grab them or review that lecture. Just before I move on, there was one more thought that I had as I was closing out this file. In this example, in this lecture, I did talk about sockets a bunch as well, because that's the other way that you can do file IO. There is no questions on the test about sockets, so you can ignore that part, which is the second method that's in this particular file. That's the replit that you were looking at. So again, for the test, all you need to know how to do is open a file, read data, close the file, and also you should know how to write data to a file. If you know that and you know how to do the try and catch, then life is good. You don't need anything else. All right, so that's the end of file IO. The next thing that we are going to talk about are threads. And again, I'm just going to refer back to a previous lecture's replit rather than writing something new. So with regard to threads, you just need a basic idea. Threads are the way that you can have more than one thing running at a time. And in order to make a thread in the world of Java, you define an object, and that object must implement runnable, which is a built-in interface that you obviously have to implement. In order to implement runnable, you must define a method called run, and whatever you put in that method run is what's going to happen when that thread is executing. This one was the weird horse race. The details of the horse are not what's important. It's that you understand there has to be a method, and it has to implement runnable, and it has to have a method called run, which is actually what's going to happen when that thread is created. Over in your main method, you would then create a version of that object, an object of that class. You obviously do that normally as horse in this case because it's called horse. H1 equals new horse. And then you're going to define a thread. So you will say thread T1 equals new thread. And then you pass it the object that you just created. And then you call start on that thread. T1.start. That tells it to start that thread and start it executing. In this example, I did 3 horses and 3 threads, all 3 of which started simultaneously, and you got the fun little horse race where the horses were running across the screen. The details of all that are not what's important. The thing that you must know is that you would have to have an object. The object has to implement runnable. The object must have a method called run, and then you call thread, new thread, and start. That's how it works in the in the Java world. Over in the C world, you still have to have a object, which in our case was the horse, but you don't implement an interface in that case. You just create the object, and you can have whatever method you want. It doesn't need to be called run. Down in your actual main is where you do the magic there. You say thread t1 equals new thread, and what you pass it is the location that you want to start in the object. So you say new thread start, and then you pass it a object.method name that you want it to actually run code from. So in this case, that's my horse, and it's horse.startRace, which is a method up in, there it is, a method inside of the class horse. So that's what I was calling. So I'm calling horse.startRace. And I'm doing that by creating a new horse, h1, and calling h1 start race. So if you're a C# student, you basically need to memorize that line. That is the way that you create a thread and that tell it what code you want it to run. And you can have obviously as many of those. It's important to know that you can have more than one thread. The threads can be running simultaneously next to each other. And you can also send a thread to sleep. That happens in both C# and in Java. It's the same syntax. You call thread.sleep. The only thing that's different between the two of them is whether it's a capital S or a lowercase s as usual. So that's what you need to know about threads, which is how to start one, basically how they're defined and what their purpose is. If you know that, you're good to go on threads. Okay, that brings me to the end. I realize this has been a long lecture, and that's why I've been trying to rush through the things that I wanted to make sure that you are aware of. Test is next week. You need to take it between Monday and Tuesday. It will take 2 hours, lockdown browser, all that stuff. Don't cheat or we'll kill you. There are 10 questions at this moment in time. You will have to write code for pretty much all 10 of them. One of the questions is going to be about a 2D array. One of the questions is going to be about recursion. One of the questions is going to be about a linked list. One of the questions is going to be about interfaces and abstract classes. One of the questions is going to be about threading. One of the questions is going to be about pass by reference. One of the questions is going to be about stacks and queues. One of the questions is going to be about reading and writing from a text file. Those are the things that I've covered in today's lecture. Those are the things that are currently on the test. It is possible that another question gets added, in which case, well, you're on your own on that one. But if you know all of the things that I covered in today's lecture, then you should be able to ace the test. You definitely need to be able to write all of this. So make sure that you're not just watching this video and going, yeah, got it. You actually will have to remember how to start a thread inside of your code. So make sure that you remember the syntax of each of those individual bits. Obviously, you can go back and reread or rewatch this video. You can go back and rewatch any of the videos. They're all on YouTube. If you go to YouTube and you look for my channel, which you can find by searching for Enda Sullivan. Oh, it suddenly got dark in here. Okay, you search for Enda Sullivan, then you will end up with all of the lectures from the semester. So if there's something that didn't make sense in today's lecture, just go back and re-watch the lecture that covered the information. People also watch Math Concepts for Kids. So there you go. That one might help you too. Who knows? But if you have specific questions, you're certainly welcome to go back and look at any of the lectures. They're all there. This one's obviously going to be posted there in a couple of minutes as well. So if you have any questions, feel free to email me. I will respond right up to the day of the test. But once Monday starts, I'm not going to respond about questions. I hope you guys have a phenomenal break over the holidays. I would ask that you make sure you send me some feedback on how you felt that the class went, which you're supposed to do in, I think it's in D2L or in L Express or somewhere like that. But if you have any individual feedback that you want to send me, by all means, send it to me in an email, or, stick it on Rate My Professor or whatever you want to do. But yeah, I would like to know if you found the class useful and helpful, and I hope you guys have a great break. Good luck on the final exam. You're going to do great. I hope you did well on your lab final. And I hope to see you around on campus at some point when the pandemic is over, if you're in this kind of area. So feel free to always stop by. And if you ever need anything in the future, don't hesitate to reach out and ask. I'm always happy to help people with other classes or stuff that comes up. I'm over here in Norton Hall. You're always welcome to stop by. So you guys have a phenomenal night, and I'm done. Bye.